Good morning. All right, we're going to finish up 2.6 today and then probably get through most of 2.7. Just a reminder, the homework that goes through 2.8, I've got set to be due Wednesday at midnight. That could even get pushed back to the end of the week. We'll kind of see how far we get today, but we should definitely finish it by the end of this week. So just again, a reminder that the test will follow as soon as we're done with this unit. So kind of my goal right now is to finish up the rest of this unit by Wednesday, probably review on Thursday, and then post the test early next week. Next week is actually spring break, Wednesday through Friday. So the goal would be to have it due Tuesday at midnight, so it's due before the break, which means I would probably open it on Sunday night at midnight to give you that 48 hours. So Monday and Tuesday would be your 2 days to work on it next week. Okay, so that's kind of my plan right now. Finish up Wednesday, review Thursday, test Monday, Tuesday of next week. Okay. Any questions, comments, concerns before we get started today? All right. So even and odd functions. Okay, so we're going to let f be some function, and we're going to say that f is even if f of negative x is equal to f of x. What that means is if we substitute a negative x value into our function and we simplify it and we get the same function that we started with, then we know we have an even function. All even functions are going to be symmetric about the y-axis. Okay, so that first graph there shows us what an even function would look like. Okay, so for all of our x's, when we substitute a negative x, we get the same thing. That gives us symmetry about the y-axis. Now, if we substitute a negative x into our function and we get the opposite of the function that we started with, so negative f of x, then we would say that that function is odd, and that has symmetry about the origin. Okay, and so we can see that in the second graph. That's what origin symmetry would look like. Notice it's a rotational symmetry around the origin. So the stuff in the first quadrant, if you were to rotate that 180 degrees, would give you the stuff in the third quadrant there. Okay, so that's what we mean when we say we have odd function symmetric about the origin. And in both cases, we're substituting a negative x into the function and just saying, do we get the same function, the opposite of the function we started with? And if neither one of those things happen, then it's neither even nor odd. Okay, so that is an option also. All right, so we just want to determine here whether each of these functions is even, odd, or neither. So again, the way we're going to test that is we're just going to plug in a negative x everywhere we see an x. So for this first one here, we've got f of negative x. It's going to give us negative x to the fifth plus negative x. So now we just need to simplify that to see if we get the same function, the opposite of the function we started with, or neither one of those. If I raise negative x to the fifth power, what's that going to give us? Good, right? So a negative to an odd power is going to stay negative. So we have negative x to the fifth. And then plus a negative x is just the same thing as minus x, right? So I can write that as minus x. So now let's start with the question, is that the same function that we started with? It's not, right? So we know it's not an even function. Now we ask ourselves, is that the opposite of the function that we started with? It is, right? So in this case, we started with a positive x to the fifth and a positive x. We ended up with a negative x to the fifth and a negative x. That's the opposite of what we started with. And so we can say that this function here is odd. And if you really wanted to, right, you could factor out the negative and say this is negative x to the fifth plus x, right? So you can really see there that that is the opposite of x to the fifth plus x. Any questions on that one now? All right, let's look at g of x. So again, substitute a negative x. So we're going to get 1 minus negative x to the fourth. Okay. Now, if we simplify that, what's that going to give us? Okay, so be careful here, right? Because it does look like we've got a back-to-back negative, which might become positive. But if we go through our order of operations, we'd have 1 minus, we'd go ahead and do the exponent first, right? Well, negative x to the fourth power, because it's an even power, is going to become positive. So that just becomes an x to the fourth power. And so really, we're just left with 1 minus x to the fourth in this case. Any questions about how I got that? Okay, now again, the questions are, is that the same function that we started with? It is this time, right? So 1 minus x to the fourth is the original function. So what type of function do we have this time? This one is even. Good. Any questions on g of x? All right, and then h of x. We're just going to substitute a negative x. So we get 2 times negative x minus negative x squared. And if we simplify this, what are we going to get? Okay, so negative 2x for the first term, right? And then just like the last one, we keep the minus sign because we would do the exponent first. And so that's going to give us negative x squared becomes a positive x squared. So it just looks like that now. And so again, just be very careful when you got those exponents. Do the exponent before you do the subtraction piece. And so in this case, it already becomes a positive. So we're just subtracting a positive x squared in that case. Any questions about how I got that? Okay, so now we go through our questions. Is that the same function we started with? Sorry, I my here. Okay. That's right. So Haley, the first step is to just make all of your x's negative, right? And then we simplify from there. Okay. So like people said, this is not the same function we started with. Is it the opposite of the function that we started with? It's also not the opposite, right? Because we started with a 2x and a negative x squared. We got a negative 2x, but we kept the negative x squared. So this is not the opposite. So in this case, we would have to say this is neither even nor odd, which means graphically, right, we have no symmetry in terms of y-axis or origin. Any questions on finding even or odd for any of those functions now? All right, so again, process is always going to be plug in your negative x, simplify. If you get the same function you started with, it's even. If you get the opposite of the function you started with, it's odd. And if neither one of those things happens, then you just say that it's neither. All right, so that's all there is in that section, right? That was the last example. So we're going to jump into 3.4 now. Sorry, I misspoke. 2.7. Okay. 2.7, which is combining functions. All right, so what we're going to look at in this section is how do we add, subtract, multiply, and divide functions. And then we're also going to look at what's called composite functions, where we actually compose functions one within another. Okay, so we'll start with the addition, subtraction, multiplication, division piece. So if we have f plus g of x, that just means that we're adding the f of x function and the g of x function together. Now, in terms of domain, to find the domain of an addition of two functions, we're going to take the domain of the first function, the f of x, the domain of the g of x, and then we're going to find the intersection, just the overlap of those two domains. Okay, and that's going to give us the domain of our sum. Same thing with subtraction. We're just subtracting f of x minus g of x, simplifying as much as you can, and then to find the domain of that difference, we're just going to find the overlap of the domains of each function. Right. The product, multiplication, again, we're just multiplying the two functions together, simplify as you can, and then to find the domain, again, it's just the intersection of those two domains. Now, the only one that's slightly different now is the division, because we can't have 0 in the denominator. When we find the domain, it is the intersection of the two, but we also have to keep in mind that g of x can't be equal to 0. Okay, so that's the one additional piece when you're doing the division, is we can't have 0 in the denominator. But in general, right, you're just doing your basic operations, addition, subtraction, multiplication, division, simplifying these functions once you do that, and then to find the domain, that's the key part, right, is just to find the overlap or the intersection between the two domains. All right, so let's take a look at these two functions here. Again, we're just looking for addition, subtraction, multiplication, and division of each of those functions. Okay, so I'm going to start with f plus g of x, which means I'm just adding the f of x and the g of x functions together. Okay, so when I do that in this case, I start with the f of x. We have 1 over x minus 2 plus the g of x function, which is square root of x. Now, in this case, there are no like terms. We don't really need to combine anything, and so I can just leave my answer like that. That is f plus g of x. It is as simple as that, right? F of x plus g of x is just 1 over x minus 2 plus the square root of x, and we're done. Now, let's talk about domain of this function. So remember, we said we want to think about the overlap between the two domains that we have here. Well, how are we going to find the domain of f of x? So the 1 over x minus 2. It's we need to think about what x can't be, and in this case, the denominator can't be 0, right? Because we have a fraction. So we would say that x minus 2 cannot be equal to 0. So what does that mean that x can't be equal to then? X can't be positive 2. Good. X cannot be equal to 2. Now let's look at the g of x function. Are there any restrictions on the g of x function? We can't have a negative inside the square root, so we would say that x has to be greater than or equal to 0 in this case. So now we're going to take both of those domains and we're going to put them together, right? We're going to think about their intersection. So if x has to be greater than or equal to 0 and x cannot be equal to 2, what would that domain look like in interval notation? Good. So we start with 0. That's going to have a bracket because it's equal to 0. We're going to go up to 2 with a parenthesis because we don't want to include the 2. Then we have our union, and we're going to go from 2 to positive infinity. So in terms of the domain, just make sure you're looking at the domain of f, looking at the domain of g, and then putting both of those domains together now. That's going to give us the domain of that sum. Any questions on that first one? All right, now let's look at f minus g. So f minus g of x. Again, all we're doing is taking the f of x function, subtracting the g of x function, so it's going to look very similar to the first one, except there's going to be a minus there. We have 1 over x minus 2 minus the square root of x. Now, in terms of domain, remember the last slide said that for addition, subtraction, and multiplication, all we have to do is look for the intersection of a and b, the intersection of the two domains. We already found that for f plus g. It's going to be exactly the same for f minus g, right? So we don't have to do any additional work. We know that this domain is also 0 to 2, 2 to infinity. Any questions on the subtraction one now? All right, let's look at f times g. So f times g of x. So this time we're multiplying our two functions together. So we have 1 over x minus 2 times the square root of x. Now, this time we could clean that up a little bit. So I'm just going to actually multiply the square root of x into the numerator here. And so I can rewrite this as the square root of x over x minus 2. And so always just clean it up as much as you possibly can, right? So in this case, the addition and subtraction, without finding a common denominator, we can't really combine those. But in this case, the multiplication, I can just multiply the 1 and the square root of x. All right. Now, what about the domain? What's our domain going to be? It's the same, right? So just like I said before, addition, subtraction, multiplication, all going to have that same domain. No additional work necessary. This is still 0 to 2, 2 to infinity. Right? And if you forget that, you can still look at the final answer that we got there. We still have that square root. That means x has to be greater than or equal to 0. We still have x minus 2 in the denominator. That means x can't be equal to 2. That's going to give us that same domain here. Any questions on the multiplication? All right. Then f divided by g. We're taking the f function, 1 over x minus 2. We're dividing it by the square root of x. Now, we can't leave a compound fraction there, so what are we going to have to do to simplify that? So multiply top and bottom by square root of x. Not quite, because if we did that, that would give us still a fraction in the numerator, and it would just give us an x down in the denominator. So we need to multiply by the reciprocal, right? That way we actually get rid of the fraction within a fraction. We're going to have 1 over x minus 2 times 1 over the square root of x. Okay, and so when we do that now, 1 times 1 is 1. And now we're left with the square root of x times x minus 2 in our denominator. So just remember, if you're dividing and it involves fractions, you can always just multiply by the reciprocal. And in this case, we just get that. Now, once we have that, now let's think about the domain. So remember, the one additional thing we have to keep in mind here is that the g of x function can't be equal to 0 because we divided by it, right? It's in our denominator now. So what's our domain going to look like this time? Good. So the only additional restriction is that x cannot be equal to 0 anymore because that would give us 0 in the denominator. So we're just not going to include the 0. We still have the restriction at 2. And we still want to be greater than 0 now. So we're still going to go to infinity. So that's the only thing that changes between the other three and this one now is because we have that x in the denominator. 0 would give us 0 in the denominator, so we can't include it. So we use parentheses instead of brackets. Any questions on that one now? Yes. So if you're looking at addition, subtraction, multiplication, those domains are always going to be identical. Okay, so every single time, no matter what the functions are, okay, your addition, subtraction, multiplication, those domains are the same. Then the division one, you're always going to have that one additional restriction that your f of x can't be equal to 0. So it's still going to be pretty similar to the other ones. You're probably just going to have one extra restriction on that domain. Now, it could technically be more than that depending on how complex that g of x function is, but it still should be pretty similar to the other ones with just some additional restrictions that they did not have. Okay. Does that answer your question, Haley? Okay. Any other questions there? All right, let's take a look now at the bottom. Now we want to find f plus g of 4, right? So just substituting 4 into our f plus g function. We've already found f plus g, so we're just substituting it right in there. So that's going to be 1 over 4 minus 2 plus the square root of 4. So now we simplify that. So what's 1 over 4 minus 2 going to be? One half, good. And what's the square root of 4? 2. And then 1 half plus 2 is going to give us what? 5 halves, right? So, or if you prefer the decimal, 2.5 is fine. Okay, but 5 halves will be our answer there. And then f minus g of 4. Same thing, we're substituting 4 into our f minus g function. So that's 1 over 4 minus 2 minus square root of 4. We should get the same thing for both of these terms, 1 half minus 2 this time. So what's 1 half minus 2 going to give us? Negative 3 halves. Good. Any questions on those first two? All right, f times g. Again, I already know what f times g is, so I can just substitute 4 right into that function. So you've got square root of 4 over 4 minus 2. Simplifying that now, we already said the square root of 4 is 2. 4 minus 2 is 2. And so our answer is going to be what? 1. Good. All right, and then finally we have f divided by g of 4. So again, I'm substituting into what we got down there. That was 1 over square root of 4 times 4 minus 2. So if we simplify that now, we have 1 over square root of 4 was 2. 4 minus 2 is also 2. And so what's that answer going to be? 1/4. That's it. Any questions on those now? All right. We're going to skip example 2. Right, composition of functions now. Okay, so if we're given two functions, f and g, the composite function, which we read as f of g, is defined as follows. Okay, so again, this is read f of g of x. Okay, so we're basically taking whatever the g of x function is. I'm going to be calling this the inside function now. And then the f function is what I'm going to call the outside function. We're substituting whatever that inside function is into the outside function, and that's going to give us our new composite function. So we read that as f of g of x. G of x, whatever comes second, is always the inside function. We're substituting that function into the other function now. All right, so let's take a look at these. We want to find f of g and g of f. Okay, and then we'll talk about the domains of each. So f of g, remember that means f of g of x. So what I'm going to do first here is I'm going to look at that inside function, and I'm actually going to substitute the function in there. So what is our g of x function this time? X minus 3. Good. So in place of g of x now, I'm going to put x minus 3. I'm finding f of x minus 3. Now that I've got that, now I can take the x minus 3 and I can substitute it into the f function. So if I substitute x minus 3 into the f function everywhere that I see an x, what's that going to look like? Good. So x becomes x minus 3, and then we're raising that to the second power. So we just get x minus 3 all squared. So again, start with that inside function. In this case, that's the g of x. Replace g of x with x minus 3. And then whatever we get there, we're substituting that into the outside function. So substitute that into the f function to get x minus 3 squared. Any questions on finding that function now? All right, now, in terms of finding domain for these, we have to look at our final answer, but we also have to consider the inside function. Okay, so I'm looking at the g of x function and the final answer this time. Are there any restrictions on the final answer, the x minus 3 squared? No. right? So this piece right here is negative infinity to positive infinity, no restrictions. Now let's look at the g of x function. So g of x was x minus 3. Are there any restrictions on that inside function? There's not, right? X minus 3 is all real numbers also. So negative infinity to positive infinity. And now I'm just going to take the intersection of those two things. Neither one of them has any restrictions. So that means my domain this time is going to be all real numbers. But you'll see on the next example, right, that if we have any restrictions on either one of those, we have to include it in our domain for the overall. Okay, so look at your final answer, look at the inside function, take those two things together, and that'll give you your domain for the composite now. Any questions on f of g of x now? All right, now we also want to find g of f. So g of f of x, that's going to be, oops, start with your g, f of x. Okay, so what's our inside function this time? The x squared, good. So f of x is on what's on the inside, f of x is x squared. So this time we're looking for g of x squared, which means I'm going to take the x squared now and I'm going to substitute it into the g function. If I do that, what's that going to give us? Good. X squared minus 3. Any questions on finding g of f of x now? All right, now, same thing with domain. We look at our final answer and we look at the inside function. So looking at the final answer, x squared minus 3, are there any restrictions on that domain? There's not, right? X squared minus 3, all real numbers, no restrictions there. What's our inside function this time? The x squared, right? So the f of x function was the inside. Are there any restrictions on f of x? There's not, right? So this also, all real numbers. Putting that together now, the domain for our composite then is also going to be all real numbers. Any questions on the composite functions or their domains now? All right, f of g of 5. Well, we already know what f of g of x is, so we're just going to substitute 5 into that function. That's going to give us 5 minus 3 all squared. And so what would that give us if we simplify? 4, good, right? So parentheses first, sorry about that. It's going to give us 2 squared, and 2 squared is 4. Now let's look at g of f of 5. So again, we already know g of f, so we can just substitute 5 into that function. This time that's going to be 5 squared minus 3. And so what would that give us? 22, good. So 25 minus 3, which is 22. So notice here, right, f of g and g of f are not the same function, and then g of f of 5 and f of g of 5 do not give us the same result, okay? So when we do composite functions, the order there really does matter because that's going to determine which one's the inside and which one's the outside. So just be very careful in how you order these things when you're looking for them. Any questions on any of the pieces of that one now? I was supposed to find g of f of 7. I'm sorry. We found g of f of 5. 7 would be the same. Just substitute 7 instead, right? And you get a different answer. All right, so now we got two different functions, square root of x and square root of 2 minus x. And again, we want to find f of g, g of f. But this time we also want to find f of f and g of g. So we're going to find all four of those and their domains. All right, so if we start with f of g here, we can write that as f of g of x. So what's the inside function going to be this time? The square root of 2 minus x. Good. So we're looking for f of square root of 2 minus x. So now, if we substitute that into the f of x function, what's that going to give us? Good. Right? It becomes the square root of the square root of 2 minus x. So we're taking the square root of 2 minus x, we're substituting it into this function here, and so that x inside the square root becomes square root of 2 minus x. Now, if you have the square root of the square root of 2 minus x, is there a way that we could rewrite that? It's a fourth root, right? So because the index of each one of those is an understood 2, right? They're both square roots. We can multiply those together, and that's going to give us the fourth root of 2 minus x. Now, that only works if everything is inside both of those radicals, right? So the 2 minus x is inside both of the square roots, and so that's why we can rewrite it as a fourth root now. Any questions on getting f of g of x now? Okay, now let's think about the domain. So again, we have to look at both the final answer and the inside function here. So if I look at my final answer, are there restrictions on that domain? Okay, good. So we know what's inside the radical because it's an even index, right? It's a fourth root now, has to be greater than or equal to 0. So we're going to say 2 minus x must be greater than or equal to 0. Now we also need to look at the inside function, right? This time the inside function was the g of x. So looking up here at g of x, are there restrictions on the g of x function? Same thing, right? So in this case, the 2 minus x is inside of a square root. So we would get 2 minus x must be greater than or equal to 0 for that one also. Okay, so we really only need to solve one of them, right? Because they're going to be the same restriction. Okay, but you'll see on some of these other ones, we don't get the same restriction and we need to include both. Okay, but this one works out to be the same. So if I solve this now, it's kind of up to you how you want to do it. I'm going to subtract the 2, so we get negative x greater than or equal to negative 2. And then we would have to do what? divide by the negative, which means we have to flip our sign. Good. So that's going to give us x is less than or equal to positive 2. And again, this one's going to give us the exact same restriction, right? So we don't have to worry about there being multiple. So now if I write that in interval notation, what's that domain going to look like? Good. So we're going to have, so be careful here, right? If we want x to be less than or equal to 2, we actually need to start where? At negative infinity, right? So this is actually going from negative infinity up to positive 2, and then with a bracket on the 2, okay? Any questions on that domain now? All right, so let's look at g of f. So g of f of x. So what's our inside function this time? Okay, good, the square root of x. So we're finding g of the square root of x. So if I substitute that in, what's that going to give us? Good, so it's the square root of 2 minus the square root of x. So I'm just taking that square root of x, substituting it in place of the x here in the g function. So that x right there becomes a square root of x. So we get square root of 2 minus square root of x. Any questions about how I got g of f of x now? All right, let's think about domain now. So look at your final answer. What restrictions are we going to have now? Okay, so the x has to be greater than or equal to 0, but why? Where does that come from? That's the square root of x piece, right? So that's really the fact that we substituted an f of x in there. That's what gives us the x must be greater than or equal to 0. Now, what about the final answer, though? How are we going to find that restriction? Okay, so not quite. So the entire 2 minus square root of x has to be greater than or equal to 0, right? So I take everything that's inside the big square root now, and I say 2 minus square root of x must be greater than or equal to 0. Okay, so that's what we get from the final answer. And then the fact that our inside function was square root of x also tells us that x has to be greater than or equal to 0 now. Okay, so this time we will get two different restrictions, and we're going to have to put them together. So if we look at this first one, again, I'm going to subtract the 2. So that gives us negative square root of x greater than or equal to negative 2. And then we can do what? So before we square both sides, we actually need to get rid of the negative, okay? Because that's actually going to change what our sign is. So I'm going to divide both sides by the negative here to get square root of x less than or equal to positive 2. And now to get rid of my square root, now I'm going to square both sides. And that's going to give us x is less than or equal to positive 4. Just make sure you get rid of the negative first, right, so that you know which way the sign's going to go, and then we can square both sides. All right, so now put all that together. So what's that domain going to look like if I put all of those restrictions together? Good, right? We need to be greater than or equal to 0, but also less than or equal to 4. So we're only looking at values between 0 and 4 now. Any questions on that one? All right, f of f. So now we're composing a function with itself. Okay, so what's our inside function this time? Square root of x. So we're taking f of the square root of x. So if I substitute that in now, what's that going to give us? Good, right? So it's the square root of the square root of x. And again, we can rewrite that as the fourth root of x now. So now, to find the domain, we need to look at the final answer. And we also need to look at the inside function. What's our restriction going to be? Good. X has to be greater than or equal to 0 for both, right? So the final answer there, because it's an even root, that x has to be greater than or equal to 0. Inside function is square root of x, same thing. And so now when we write that in interval notation, what would that look like? Good. 0 to infinity, including the 0 this time, right? All right, now I'm going to try to get through this last one real quick before we run out of time. So g of g, so I'm looking for g of x. Inside function this time is square root of 2 minus x. So I'm substituting that into the g function, which is going to give us the square root of 2 minus the square root of 2 minus x. Now, because not everything is inside both square roots this time, we cannot simplify that. Okay, so that's as simple as that's going to get. Now, in terms of our domain, if I look at the final answer, we're going to have 2 minus the square root of 2 minus x has to be greater than or equal to 0. So everything inside that square root has to be greater than or equal to 0. Then the inside function is just the g of x, which means that 2 minus x must also be greater than or equal to 0. Okay, so then if I solve this, we're going to have negative square root of 2 minus x greater than or equal to negative 2. Divide by the negative, so we end up with the square root of 2 minus x is less than or equal to positive 2. Square both sides, 2 minus x less than or equal to 4. Then we can actually move the 2 over. So that's going to give us negative x less than or equal to 2. And then dividing by the negative, x is greater than or equal to negative 2. And then this one here, right, if I just move the negative 2 over, we get negative x is greater than or equal to negative 2. Divide by the negative, x is less than or equal to 2. And so our final answer here is everything between negative 2 and positive 2. So that would be our domain. Okay, so I just wanted to get the work up there. You can hang out and ask me questions if you have them. Otherwise, I know people have other places to be, so I'm going to let you go. Don't forget, continue to work on homework. Send me questions as you have them. We should be able to finish up by the end of this week, and then our test will be next week. Okay, have a great day, and I will see you all Wednesday.